मेल आईडी चाहिए होगा उसके लिए जी।
सर ऑप्शन में सब
तुम उसको शेयर कर दो।
है ना, आप अपना मेल बताइए।
हाँ तो क्या है BUG6 डेटाबेस भी मेल कर दो, एसपी भी कर दो, डेटाबेस मेल भी कर दो ना, डेटाबेस भी तो चाहिए होगा। आ गया।
मैम उसको हाईलाइट कर दीजिए उसके बाद।
Fine. So, shall we begin? Okay. Yesterday, as I told you, in machine learning, there are two kinds of problem, the classification problem and the regression problem. And classification problems are where the outputs are binary in nature. That means one of the classes gets a value of 1 and the other classes get a value of 0. So the one which gets 1 is the class the data belongs to. While in regression, which is again a kind of prediction, the outputs are continuous values or real numbers. Like supposedly, I have a data which is size of the house against the price. Supposedly, I have been given these many sizes, and for each size, I have been given a price. Okay? For these many sizes, we have been given a price. And using this data, I want to know what will be the price of a size which is somewhere here, or let's say somewhere in between. Okay. Now here the output cannot be 0 or 1 because the price of a house is not 0 or 1. It is in some lakhs of rupees or some crores of rupees, whatever it is. So what I can do is I can fit a curve over this data and then extend this curve on either side to get the values which are either missing or which are in the future. And one of the ways of fitting a curve is fitting a straight line between the data points. Now you see, I took this line. There can be many lines. There can be infinitely many lines drawn if I take one point as the reference point. Do you agree? And I can draw only one line if I take 2 points as reference. I can draw only one line. So there are many lines that I can draw in between these data points. So this is called, this fitting of a line among the data points is called linear regression. Can we focus everybody here? आप computers देखना बंद कर दीजिए, please सुनिए. ठीक है? This is called linear regression. Okay, this is called linear regression. I'm fitting a line in between the data points, and how do I choose which line will be the optimal one? Okay, so what I'm going to do is I'm going to find the distance of each of the points from this line. I'm going to find the distance of each of the points from this line, and if you know coordinate geometry, a point lying below a line will give you a negative distance, while the point lying above the line will give you a positive distance. So in this case, if it happens that the sum of the negative distances is equal to the sum of the positive distances, it's going to cancel. So what I can do is I can take the square of the distances and then add them together. Then the negative one will become positive and the positive one will also be positive. So they will all add up and give you a finite value, not 0. Okay? And you know how to find the distance between the 2 points. So I know this line y is equal to mx plus c. I know this point, and for each of them I can drop a normal and I'll get the point, that the distance between the line, and that will be for any point x. If I take any point x, this distance will be w transpose x plus b, where w is the normal between the point x and the line. Okay, this is from the coordinate geometry, basic coordinate geometry. So I can forget about this if you are not getting it. Don't worry about it. Whatever rule you know, you find this point x comma y, x1 comma y1, drop a normal, take the normal distance, and square it up, and then sum it up. Okay? So there can be many lines. Like supposedly, I draw a line like this. What's going to happen? In this case, the sum of the distances will be larger because each point has moved farther away. What about this line? Again, the sum of the distances will be larger because the points have moved further away. So I'm going to choose that line for which the sum of the distances is minimum. Okay? And that line will give me the best fit line. So even though this line not crosses any of these points, I have chosen it because it's going to give me the minimum distances between all the points in comparison with this line, or in comparison with this line, or even if I draw something like this, passing through these 3 points, maybe this will be all summing to 0, while this will be summing to some positive number, which will be greater than the positive number I'm going to get by this. This is called linear regression, And once I have found this optimal line, and extend it into future, I can always drop a vertical from any point, and this will give me the price of the house given this size. Okay, and this, if I drop a normal from here for this point, and I drop a horizontal here, this side will give me the price of the house of this size. Even though I had data with respect to only these many points, I can extrapolate, go into the future, interpolate, see in between, and find the what do you call it, price of the house given the size. Is this clear?
Yes.
Wonderfully well. This is a prediction analysis, and you are doing a prediction. But this prediction is not 0, 1. You are not saying whether a house belongs to class this or class that. But what if in this data only, I do something different? I do something different. I choose a threshold. A vertical line somewhere here. Okay, I choose a threshold value and say that if the size is greater than this, the house is big. And if the size is lesser than this, the house is small. So now this becomes a classification problem. Supposedly now we are given this point and this point. I want to know whether it is a big house or a small house. Getting the point? This becomes a classification problem now. So in this case, we need a threshold value. We should decide whether I am behind this or whether I am towards the positive x-axis. Okay? And such problems can be solved using something called logistic regression. Okay? And in logistic regression, we do not fit a linear curve, we actually fit a sigmoidal function. Okay, and a sigmoidal function looks something like this. It's the general formula for a sigmoidal function. It looks something like this, and the curve looks something like this. So whatever x you give as an input, the value of the output is squashed between 0 and 1. The value of the output is between 0 and 1. Okay? So now this value lying between 0 and 1 can be treated as probabilities. Okay? So if I draw a threshold somewhere over here, just like that case, if I draw a threshold over here, okay? Got my point? If I draw the threshold over here, and then anything that comes below this threshold, let me call this as gamma, anything coming below this threshold will be assigned to a different class, and anything coming above this threshold is going to be assigned a different class. So if I transform this data slightly differently, Okay, the size of the house is this way, and I want to classify, I choose a threshold value, I want to classify that beyond this threshold, they are big houses, and below this threshold, they are small houses. Am I right? So again, you can always fit a line like this. Am I right? I can fit a line like this, which crosses the threshold somewhere, and we can interpolate to find whether the house is big or small if I know the threshold. Okay? So if I have a size somewhere over here, and I interpolate it back, I get some value over here. And if it is beyond the threshold, I'll say it's a big house. If it is less than the threshold, it's a small house. But if you see, this line will extend towards negative infinity and positive infinity. So what you are going to get is a real number lying between minus infinity to plus infinity. So instead of fitting a curve like that, a straight line like that, if I fit a sigmoidal function like this over here, if I fit a sigmoidal function like this over here, and we choose a threshold, so this will always give me a value between 0 and 1. So even if the size goes far here, this curve is always going to saturate at 1. While in this case, it would have gone out of the board if I had to extend this line. Okay? So for prediction like this, where there are binary classes, fitting a sigmoidal function over the data like this, using some threshold learned on the basis of the data, is a much wiser attitude. Okay? And that's what we have implemented in Python. And it remains something very similar to what we have already done. So if you want to run this code, maybe he has shared with you the database as well as the link. Okay? So let's go and do it all together. Are you able to open it up in your computers?
आप सपोज शेयर किया व्हाट्सएप पे सब कुछ डेटा सेट भी है सीएसवी फाइल और दो
कलेक्शन नहीं है,
एक्सेस परमिशन नहीं व्यू पे डाल रखा है ना
एडिट का ऑप्शन नहीं है उसमें।
सर एडिट करने का ऑप्शन है ना, इसलिए मैंने
तो ऐसा करते हैं, आप लोग व्यू ही रखिए अपने अपने कंप्यूटर्स पे, अभी मत एडिट कीजिए, जब मेरा खत्म हो जाएगा तब एडिट करके चेक कीजिए।
ना आप अपनी कॉपी बना सकते हैं और कॉपी कर लीजिए और दूर का
ठीक है? So let's do it. The first thing we are going to do is we are going to import the Python libraries as we did yesterday. हाँ, वो नहीं करो
सर, इसलिए मैं व्यू पे कर रहा हूँ, सपोर्ट कर रहा हूँ। हमेशा ड्राइव को ही यूज करना होगा, गूगल ड्राइव को, या डायरेक्ट अगर हमारे फाइल डायरेक्ट सिस्टम में है तो वहां से भी हम ये कर सकते हैं कॉपी ये उसके बाद।
हाँ, डेटाबेस आपका जहां पे वहां पर से उठा लीजिए उसको। नहीं, कोलैब में बस यही होता है कि जितनी बार आप रीरन कीजिएगा उतनी बार सबको इंपोर्ट करना पड़ता है।
परमिशन मांग रही है
छोड़ो ये काम,
प्रीति मांग रही है परमिशन।
किसी को चेंज करने का।
नहीं
अच्छा,
देख नहीं पा रहा।
ठीक है, कैन यू स्टार्ट? आप लोग एडिट मत कीजिएगा, ठीक है, वरना प्रॉब्लम हो जाएगी अगर आपको यही शेयर कोड मिला है तो। हाँ, आप लोग इसको कॉपी कर लीजिए और उसके बाद उस पर एडिट कीजिए। उस कोड को एडिट मत कीजिएगा, उसकी कॉपी बना लीजिए। ठीक है, so shall we start? ठीक है, so again we will start with importing the Python libraries like NumPy, Pandas, sklearn. And then we'll load the database, read the database in a CSV format. Again, this is not human format as we showed yesterday. So let's print and see what is there. The same database that we did yesterday.
There was a question study how about using region labels. So they can just copy it from here. It will click on the press it. Just put it in the table form. And they can copy it from there besides it.
Okay, it's here. Okay, you can copy and paste if you want. Fine. And then again, we check the number of rows and columns in the database. There are 768 examples consisting of 9 variables. 8 of them are feature values, while one is the outcome or the label. Okay, here we have got the statistical parameters of the database, like the mean value, the standard deviation, the minimum value, the maximum value, and the mean values between 25%, 50%, and 75% of the data. This was all explained yesterday. Here we are giving the outcomes names as diabetic and non-diabetic. Diabetic is 1, non-diabetic is 0. And then we group the database by outcomes. So these many examples are there. Sorry, these are the mean values in the non-diabetic case, and these are the mean values in the diabetic case. Finally, we separate the data into x and y axes, where the x axis is not a single dimension; it's 8 dimensions, and then we print as c x, print as c y. Then we do Gaussianization, which is data standardization. We do a transformation so that each column of this matrix becomes Gaussian in nature with a zero mean and unit variance. And this is how it looks like after that. We do train and test split. And then we get the shape of the train and test splits which we have created. And finally, from sklearn, yesterday we were importing random forest, today we are importing logistic regression, and we are just giving it as an input. We are creating a classifier, which is, and then learning it on X train and Y train. And finally, we do the evaluation. If you want to see the training accuracy, it is 0.785, that is 28.5%, which is higher than what, which is lower than what was yesterday. It was 98% in the case of random forest. But interestingly, the accuracy on the test data will come out to be higher because this is not overfitting. Okay. Yesterday for the test data, the accuracy was lower, 75%, I guess. Huh? 70%. While today we are getting nearly 76% because generalization is better in the case of logistic regression than in the case of random forest for this database, what we are chosen. Now again, we took some random values over here and we check whether the person is diabetic or not. And the answer is person is diabetic, and I showed it to you yesterday that if I change the values here, here, and then run it once again, the person will turn out to be non-diabetic. Okay. So we did some more studies on how to create a confusion matrix out of this database for better insight into it. So what is a confusion matrix? Confusion matrix gives you a 2 cross, in this case, a 2 cross 2, it will be a 2 cross 2 matrix where it will show that the number of examples that belong to class 0 were classified as class 0. So it will be a matrix like this. Class 0, 0, class 1, and a 1 here. That means this cell shows how many entries in the database were classified to class 0, given that it belonged to the class 0. while this one will show how many entries in the database are classified as class 1, given that it was from class 1. So let's say this is X, this is Y. What about these two? So these two are the correct decisions. This is called true negative. That means it belongs to the negative class and was assigned a negative class. This is called true positive, where it belonged to the positive class and it was assigned a positive value. What about this? This is false positive. This is false positive. It belongs to the, what do you call it? Negative class, but it was given a positive class. And here, if I have something like P over here, what is this? It belongs to the first positive class, but it has been given a negative class. So this is false negative. Okay. See, how do we understand this? I usually, when I'm teaching hypothesis testing, usually to MTech and PhD students, I do teach that. Supposedly, I have a radar system. It's on some of the border areas of India, catching enemy planes in the atmosphere. Okay, so there is an enemy plane, and you detect that there is an enemy plane. This is true positive. Right? This is our own plane, or a cargo plane, or a passenger plane, and you detect it as not an enemy plane. This is true negative. You do not want to target such aeroplanes, which are, of course, our aircrafts, or a passenger aircraft, or a cargo aircraft. You just want it, if it happens to be from enemy territory, then only it should be targeted, a missile should be launched. What happens if it is an enemy plane and you detect it as a cargo plane? This is a miss. This is a miss. You missed the target where you should have launched a missile to hit it. Now it's inside your territory and it can bomb you and go back. Okay? So that is miss. It's a false negative. It should not have happened. Okay? What if it's a cargo plane or a passenger plane or your own plane and you detect it as an enemy plane and shoot it down? It's a false positive. So now, when you have a confusion matrix like this, which we have drawn over here, true positives, that means 89 people are truly detected as diabetic. They were diabetic, they have been detected as diabetic. True negative, 28 people did not have diabetes, but they have been detected as diabetic. Okay. False positive. Okay. 26 people who did not have diabetes have been detected as diabetic. False negatives, 11%. Sorry, 11 people. So there were 11 people who were diabetic but have been diagnosed as non-diabetic. Now, depending upon the problem at hand, which error should you minimize? It depends upon the problem. Like in the radar case, false positive is a very, very dangerous thing. You cannot shoot your own aircraft, you cannot shoot a passenger aircraft, you cannot shoot a cargo aircraft, because it's going to lead to deaths which are not required. Okay. Now, supposedly the person was false negative, sorry, false positive. He did not have diabetes, but has been detected as diabetic. Is this a big problem, or the person was having diabetes and has been detected as non-diabetic? Which is a bigger problem? Depends upon the kind of disease. इस disease के केस में तुम नहीं बता पाओगे इतनी आसानी से. Let's take COVID as a case. Person is COVID positive and you declare him positive negative. क्या होगा? He'll become a super spreader. So a false negative is a bigger problem in the case of COVID. False positive में क्या होगा? एक person COVID negative है, but तुमने उसे COVID positive declare कर दिया. क्या problem हो सकती है? उसको दवा चला दी जाएगी azithromycin और doxycycline. ठीक है, थोड़ा सा उसको टेंशन हो जाएगा, मे भी 2 दिन बाद फिर से टेस्ट करा लीजिए, शायद आ जाएगा। ठीक है, बट सुपर स्प्रेडर अगर हो गया तो बहुत बड़ी प्रॉब्लम हो जाएगी। सिमिलरली आई यूजुअली गिव दिस एग्जांपल ऑफ banks. You are going to the bank to get a cash and check, sorry, a check and cash. ठीक है, so now supposedly your signature does not match with the signature in the database the way it should have matched. You were the authentic person, you gave your signature but it was not matching. क्या होगा? बहुत से बहुत तुमसे 4 बार और साइन करवाएगा, ठीक है, बट फ्रॉड नहीं हो पाएगा। तो इट वाज अ फॉल्स नेगेटिव, बट दिस इज नॉट डेंजरस। बट अगर तुम्हारा सिग्नेचर नहीं था और डिटेक्ट हो गया, तब क्या होगा? तो a false positive is a dangerous thing. So it depends upon the situation, which error among the Z and the P are more dangerous. So depending upon the solution, usually false positives are a dangerous thing. So we minimize false positive at the cost of false negatives. Interestingly, आप दोनों को नहीं कर सकते हैं, ठीक है। उसकी वजह होती है कि ये थ्रेशोल्ड अगर आप शिफ्ट कीजिएगा, तो जैसे ही आप फॉल्स नेगेटिव्स को कम कीजिएगा, फॉल्स पॉजिटिव भी जो है बढ़ जाता है। So there is another visualization of it which is called the heat map. Heat map में colors होते हैं and the colors shows you the intensity of the errors and things like that. और यहाँ पर उसका कोड है, तो ये जितना लाइटर कलर है उतनी अच्छी बात है, ठीक है। बट इन दीज टू रीजन्स जितना डार्कर हो उतनी अच्छी बात है, ठीक है। यहाँ लाइट होना चाहिए इन दोनों में, ओके। तो हीट मैप इस तरीके से जो है आपको कंफ्यूजन मैट्रिक्स को दिखाने का तरीका होता है, ठीक है। Nothing much over here, nothing much over there in logistic regression as well. Let's go to something more beautiful which is called support vector machines. ये बहुत मजेदार चीज है और इसने बहुत रेवोल्यूशनाइज कर दिया मशीन लर्निंग को। वाकिफ ने दिया था ये way back in the 80s, I guess. Supposedly, we'll start with a linearly separable data. What do I mean by linearly separable data? Linearly separable data is a beautiful class of data which can be separated by drawing a line between the two classes. So supposedly, I have data like this. X's and circles. This is linearly separable because you can see I can always draw a line which will separate this class from that class. Let me call this as class CO and let me call this as class CX. जो तुमको मन करे नाम दे सकते हो, ठीक है, it's your choice. उसको अमित कह दो, उसको राजीव कह दो, कोई फर्क नहीं पड़ता है, as long as that you feed the right inputs to the system, because garbage in is garbage out. How many lines can I draw? सिर्फ एक लाइन, मैं 4 तो अभी खींच लिखा था, मैं 4 तो ऐसे ही खींच रहे, इनफिनिटली मेरी लाइन है। इतनी सारी लाइन खींच दी मैंने। इनफिनिटली मेनी लाइंस तुम खींच सकते हो to separate CX from CY, sorry, CO. Am I right? Then which line should I choose? That's always the question. Huh? किससे minimum distance? किस point से? That's the right answer, but किस point से?
median.
Median. किस चीज का median?
तो both the classes.
तुम इन दोनों क्लास के मीडियन वैल्यूज पता करोगे और उससे मिनिमम डिस्टेंस पर खींचोगे। फाइन। और कोई तरीका?
जो दो नियरेस्ट पॉइंट्स हैं,
हाँ,
वो अगर सबसे क्लोज है दोनों डेटा सेट के,
हाँ,
डिवीजन है,
Exactly that's the answer. क्यों हम बताते हैं क्या प्रॉब्लम हो रही है. Supposedly मैंने ये लाइन खींची है to separate the data. Supposedly मैंने ये लाइन खींची है to separate. देखो इन पॉइंट्स को तो कोई प्रॉब्लम नहीं है, इनको लिटरली कोई क्वेश्चन नहीं है, बट ये जो पॉइंट है इसकी रीडिंग में जरा सा भी एरर होगा तो वो इस क्लास से इस क्लास चला जाएगा. सिमिलरली ये जो पॉइंट है इसकी रीडिंग में जरा सा भी एरर होगा तो इस तरफ से इस तरफ चला जाएगा. So the line should be drawn in such a way कि जो ये क्लासेस के सबसे नजदीक वाले पॉइंट्स हैं इनको सबसे ज्यादा दूर करके रख दे. Getting my point? These should be more farther away from the line separating the two classes. So what we do is first we draw two lines which are called the marginal planes that pass through these points X and O. Okay, जो सबसे नजदीक वाले थे जहां कंफ्यूजन होने के चांसेस थे. ठीक है, we draw two planes or two lines which are called the marginal planes. ठीक है, and then we draw a line midway between the marginal planes. इस लाइन से ये पॉइंट और ये पॉइंट मैक्सिमम दूरी पे रहेंगे. And this distance between these two points is called the margin. I'm giving a cushion कि तुम इतना deviate भी कर जाओ तो कोई हर्ज नहीं है. Here also I'm giving a cushion कि इतना अगर आप deviate भी कर जाते हैं तो कोई हर्ज नहीं है. Am I right? Getting my point? So again, if you see what I'm doing is I'm taking this point and dropping a normal from here to here. I'm taking this point and dropping a normal from here to here. And the sum of the two normals should be maximum. If I do that, the kind of plane or the line I'm going to get is going to be the optimal one. And this is what support vector machine does. These two vectors or points are called the support vectors, which are closest in the plane. We first draw marginal planes passing through support vectors. They are not necessarily single points. They can be multiple points. ऐसा भी हो सकता है support vector. ऐसे भी हो सकते हैं. ठीक है, जो सबसे क्लोजेस्ट पॉइंट है जिनके मिसक्लासिफाई होने के चांसेस सबसे हाई थे. ठीक है, we pass two planes through those and then in midway between we draw the line. Okay, now look, if this is a line which is optimally dividing this CO from CX, then let me call that equation of the line as W transpose X plus B. I'm saying this line is W transpose X plus B, where X will take the value depending upon which point I choose. If I choose this point, X will be this point. And I'm going to drop a normal and check it. Okay, where W is the slope parameter. This is the line. Okay, this is the normal vector being drawn. Now, you know from coordinate geometry that if a point lies this side of this line, this quantity will be greater than 0. And if it lies between towards this side, let me call this as anything. Let it be X. So W transpose X plus B is less than 0. This implies that the data belongs to CO class, and this implies that the data belongs to Cx plus. Okay, and now in machine learning, we can always give this as +1 and as -1. Okay, I can give this as +1 and this as -1. So if I get a +1 value over here, the data belongs to the class CO, and if I give a value of -1 over here, it belongs to class Cx. Okay, getting the point? Now let me subtract this equation from this equation. So I will get W transpose, let me call this as point x1 and this as point x2. x1 minus x2, so this was my x1, this one was my x2. The 2 points which are actually lying on the marginal plane. Okay? The support vectors will give you +2. Am I right?
Yes.
This is nothing but the distance between the 2 points multiplied by the normal. Am I right? This is the distance between the 2 points multiplied by the normal. Now, if I divide this whole thing by the norm of W, the length of the normal, so I can put this over here also. Am I right? If I divide this on the both sides by the norm of W, actually what is going to happen is this is going to become unity. किसी भी वेक्टर को उसके लेंथ से अगर हम डिवाइड कर दें तो क्या मिलता है? So there was a vector W transpose which was the normal vector being dropped from there to here, and of course these two are equal in length, so they were taken as W. हमने ऐसा choose किया था. So this distance, if I maximize this distance, then I'm done. I'm going to get the straight plane. So the optimality criteria in case of SPM is that maximize 2 by norm of W under the constraint that W transpose X plus B is greater than 0 when it belongs to C naught, and W transpose X plus B is less than 0 when it belongs to CX. That's all. That's all. There's nothing more to be done. If this norm of the vector का ये वैल्यू है, अगर हम मैक्सिमम कर दें, so the plane will be. Now अब तुम जरा सोचो, मेंटली पिक्चर ड्रॉ करो कि मैंने जो ये लाइंस ऐसे ऐसे ही ली हैं, ये क्यों अच्छी लाइन है? तुम किसी और तरह से ड्रॉ करके अपने दिमाग में या पेपर पे करके देखो, तो वो मैक्सिमम जो डिस्टेंस मिलने वाला है वो इसी केस में मिलने वाला है. इसीलिए मैंने शुरू ही टेढ़ी लाइन से किया था. अगर मैंने कोई और लाइन, तुम लोग बना के देखो एक बार कुछ और लाइंस, और देखो क्या तुम उसको बना पाओगे वैसा ही, उन पॉइंट से पास करता हुआ भी रहेगा. ओके, वी कैन डू इट. अगर मैंने ऐसे लिया होगा तो अभी भी वो सपोर्ट वेक्टर से पास कर रहा है, ठीक है, बट नाउ यू सी द कुशन इज लेस, है कि नहीं? इसके बीचों बीच जब हम लाइन खींचेंगे तो ये जो दूरी मिलेगी, this is lesser than what we got in the previous case. You can visually see this. Okay, so this is what an SVM does. As far as this is easy peasy, एकदम easy, कुछ भी नहीं. प्रॉब्लम कहां से शुरू हो जाती है? प्रॉब्लम वहां से शुरू होती है when data is not linearly separable like this. If your data is like this, it's not linearly separable anymore. Can you draw a line? Is there any way that I can draw a line on this board that can separate the XS from the circles. Is there? No. There's no way. Now comes the beauty of machine learning. Just imagine I have a matrix. This is the data. I have a matrix T. Some transformation matrix T. नहीं F लिखा गया. जो some transformation matrix F. Such that when I multiply this with the circles will come out of the board. And when I multiply it with the crosses will go inside the wall. Now, don't you think this board becomes the plane in the three-dimensional space which separates this data? So the theory says that if you project the data from a lower dimensional subspace to a higher dimensional subspace using some transformation F, then your data can become linearly separable, and this F is called the kernel. This F is called the kernel. Now this kernel can be of several different kinds, like a linear kernel, which behaves like a affine transformation, ax plus y, ax plus b, an affine transform, or a polynomial transformation like a1x plus a2x square plus a3x cube plus so on, ap, xp plus a polynomial kernel, or it can be a sigmoidal kernel, or it can be a radial basis function, whatever it is. There are several different forms of kernel which can be used, where I just told you kernel is nothing but a transformation matrix such that if I transform this x, it goes inside to the wall, and if I transform the circles, they come out of the board. And as a consequence of that, this board will become an optimal plane separating the data points. Okay? This is the basic funda which is used. Use some kernel that transforms the data in such a way that they become linearly separable. Okay? Got my point? So that's what we do in SVM. And if you see a code for SVMs, here there is a sigmoidal nonlinearity being used, or a sigmoidal kernel being used. You can change this and make it a polynomial or a linear or a RBF, whatever you want to. There are certain options. If you search for SVM, SVC in a scalar, it will give you the possible polynomials. So possible kernel. See, the kernels are linear, poly, RBF, sigmoid, decomputed. You can define your own kernel yourself. Okay, so we'll do this for each of the kernels and see what happens. Yes, we have. ये तो रन किया हुआ है. Okay, so let us run this with sigmoidal kernel. And see the accuracy of the training data. 71% on the training data. Let's check its accuracy on the test data. It's 75.32. Are you all here or आप लोग distract हो गए हैं? थोड़ा सा टी ब्रेक चाहिए क्या?
लेकिन यार टी ब्रेक होता है तो लंच के
भाई देखो इस तरह की शिकायत में से करके कोई फायदा नहीं, यहाँ पर ऑर्गेनाइज नहीं किया है.
आप पूछे इसलिए बोला सर.
नहीं, टी ब्रेक के लिए आप लोग बाहर चाय पी करके एक कप आ जाएंगे. हाँ, मैं कुछ नहीं कहूंगा, मैं आंख बंद कर लूंगा, मुझे नहीं पता आप लोग कहाँ गए। ठीक है, let's change this kernel from sigmoid to RPF. Did you notice कि हमने कितना पाया? It's 75.3% when the kernel was sigmoid. Remember this value. It's 72.72 if I use the RBF kernel. Let's try the polynomial kernel. So RBF और sigmoidal almost बराबर बराबर दे रहे हैं. और गिर गया नीचे 70% पे चला गया. Let's try the linear kernel. And this is 77.27. So if you see in this case, for this database, having a linear kernel is a wonderful thing. So it again depends upon what kind of database you are using, what kind of transformation will be helpful. Maybe हमारा database बहुत beautifully पहले से ही linearly separable type form में है, बहुत कम overlap है, इसलिए कोई बहुत ही complex mapping करने की जरूरत नहीं है. ठीक है, so if we generate the what do you call it, heat map and all. So now if you see true positive बढ़ करके 91 चला गया, true negative अभी 28 है, false positive अभी भी 26 है, false negative गिर गया. It has come down to 9 from, I guess it was 11 earlier. ठीक है, it was 11. तो ये दो वैल्यू सेम रही, ये दो बढ़ गई, ये दो घट गया. एंड ऑफ कोर्स अगर कहीं बढ़ रहा है तो कहीं घटना चाहिए. ठीक है, और ऑफ कोर्स एरर घटा है तो इसका हीट मैप भी जो है वो थोड़ा चेंज हुआ होगा. ओके, तो दिस इज हाउ इट लुक्स नाउ. ठीक है, और लाइटर हो गया है ये, पता नहीं चला बट दिस हैज बिकम अ बिट लाइटर. टिल हियर was what I had planned. Do you want to run these courses on your own, or should I continue a little of theory of neural nets? Just a theory. I'm not going to do any code running for neural net. I just want to a bit of theory of neural nets. ठीक है, क्योंकि neural nets बहुत hot है और I guess I'm doing good. तो maybe तुम्हें neural net ज़्यादा अच्छे से समझ में आने लगेगा इसके बाद. So जिन्होंने मेरी क्लास पहले भी अटेंड की है, they know what example I'm going to go with. This is the example which I use for describing a perceptron. A perceptron is the basic building block of a neural network. Okay, क्या हो गया? The perceptron is the basic building block of a neural network. Perceptron is nothing but it's a computational unit which takes input as a weighted combination of all inputs. So if I have three inputs, x1, x2, x3. Okay, I'm going to weight each one of them, W1, W2, W3. Whatever comes here will be added up. So there will be a summation, weighted combination of each of the inputs, and this is called the local activation V. Local activation V. So V will be equal to W1x1 plus W2x2 plus W3x3. Okay? And this local activation will be passed through a non-linearity. Let me say this non-linearity is a hard limiter. Okay? So if it goes beyond a particular value, if the value of V is beyond a particular value, I'm going to give an output as 1. If it is below that value, we are going to give it as a value of -1. Okay? So the example usually I go with, which I read somewhere or heard somewhere, supposedly I want to watch a movie. Okay? And there are 3 parameters based on which I am going to decide whether I'm going to watch the movie or not. पहला पैरामीटर, महीना का शुरू है कि आखिर है। फर्स्ट पैरामीटर, क्योंकि स्टाइपेंड आ गई है या अगली आने वाली है, अभी पिछला महीना का तो उड़ गया है, क्योंकि पहले हफ्ते में जब स्टाइपेंड आती है तो बाहर खेल भी चलता है, फिल्म भी होती है, कपड़े भी बिना मतलब खरीद लिए जाते हैं, जूते वगैरह भी आ जाते हैं, और वो ऑलमोस्ट हर दूसरे दिन पार्टी हो जाती है। बाय द एंड ऑफ द मंथ आपको मांगने चाहने की नौबत आ गई होती है, ठीक है। Got a point. First parameter is that whether I have enough money or not, surplus money or not. ठीक है, that is x1. ठीक है, do I have enough money? x2, star cast. कौन लोग हैं फिल्म में? There are certain heroes and actresses जिनकी फिल्म देखना हमको बहुत पसंद होता है। हम लोगों को सलमान खान की लगी तो जाना ही है किसी भी हाल में, ठीक है, या मैं भी दीपिका पादुकोणे हैं तो उनकी फिल्म है तो देखना ही देना है, या पता नहीं आजकल तो बहुत सारे नाम को पता भी नहीं है। पंकज त्रिपाठी, नो आइडिया। न्यूरलेट्स, ये किस पे आ रहा है? न्यूरलेट्स किसी चैनल पे आता है तो मुझे नहीं पता है। आई नो पंकज त्रिपाठी वाज अ स्टेज आर्टिस्ट। मैं ये याद कर रहा था कि मैंने उसकी कोई फिल्म देखी भी है कि नहीं। आई डोंट रिमेंबर उसे किसी जगह देखा है मैंने किसी फिल्म में। हाँ, नहीं देखा है। हाँ, मैंने उसे कहीं देखा है कि नहीं किसी फिल्म में, वही सोच रहे हैं कहाँ देखा है।
सर वासेपुर में सुल्तान देखे हैं कैरेक्टर किस जो पैसा का
एनीवे जो भी है, ठीक है। स्टार कास्ट। पॉइंट नंबर 3, आर देयर पार्टनर इन क्राइम? दोस्त लोग जाएंगे कि नहीं जाएंगे, ठीक है। नाउ among this I give each of them some weights, W1, W2, W3. Supposedly महीना का एंड है, महीने का एंड है, और ये दोनों वेटेजेस सही मिल भी गए हैं तो भी आप नहीं जा पाएंगे। गेटिंग माय पॉइंट? पैसा नहीं है, दोस्त भी तो वही है भाई, उसका भी खत्म हो रहा होगा, वो ये सोच रहा होगा तुम नहीं दे दोगे मेरा। You get my point. Depending upon the condition, weights are chosen. ठीक है, या supposedly स्टार कास्ट ऐसा है कि हम कुछ छोड़ ही नहीं सकते हैं, तो उधार लेकर अगले महीने का भी जो है, तो इट डजंट मैटर ये वैल्यू क्या था, ये वैल्यू क्या था, कोई जा रहा है कि नहीं जा रहा है, एकदम पहली वाली सीट भी मिल रही है, इसमें ऐसे कैसे लिखना पड़ता है, तो भी हम जाएंगे क्योंकि भाई मेरा फेवरेट हीरो की फिल्म है। So that's how we define it. It's the weights which are actually going to define whether your V value is going to cross the threshold or not. And the output Y is some function f, or usually they denote it by a function phi of V, where phi is a non-linear function. And the basic theory of neural networks says that, remember this, I just said it for SVM. The basic theory of neural net says that if you project a low-dimensional data to higher dimensional subspace using a non-linear function, then the class space can increase the class separability. Now, this is what a perceptron is. Now, let me give you a few examples. I'm going to draw the truth table of AND logic. क्या होता है आउटपुट AND लॉजिक का 0 0 1. Let me represent 0 by circle and 1 by a cross in this plane. Okay, where this is x value, this is y value. So when x is 0, y is 0, z is 0. Okay, when x is 0, y is 1, still a 0. When x is 0, x is 1, y is 0, this is still a 0. But when x is 1 and y is 1, this is 1. Now look at this equation. This is nothing but the equation of a plane. Had it been two dimensions, this would have been two inputs, then y would have been equal to w1, rather z would have been w1x plus w2y. Am I right? For this case. That means a perceptron draws a line in some space depending upon the number of input dimensions. तो अगर हमने तीन inputs लिए हैं तो it will be a space. हमने दो input लिया है तो it will be a plane like this. हमने चार input लिया होता तो और बड़ा space होता तो hyperplanes हो जाते. Now that means it draws a plane in the space just like SVM to separate the data. Am I right? I can still draw a line. Am I right? But supposedly this was XOR logic. XOR logic में जब odd number of inputs 1 होते हैं तो output 1 होता है. That's how it goes. That's the limitation of a perceptron. In such cases, this was the example जिसने 60s में literally doom कर दिया था neural nets को कि XOR logic को कैसे solve करेंगे, because a perceptron can draw a line. A perceptron can draw a line which can separate one class from the other class, because I just showed you that this is the equation for two parameter case, this is the equation for three parameter case, and it's always a plane or a line, hyperplane or a line, whatever it is. But XOR के case में you cannot draw a line to separate the XS from the circles. But I can draw two lines that will do it. If it lies below this line or above this line, it is a circle. If it lies above this line and below this line, it is a cross. So that means if I connect two perceptrons in a beautiful way, in a logical way, I can do this because each perceptron will draw one line. And in this way, we can have multiple lines. And this gave rise to the case of multi-layer perceptrons or a single layer perceptron or a neural network, where neural networks are nothing but arrangement of perceptrons into layers, okay, which do the same thing. Supposedly, we have two input x1, x2, and we give it to a neural network which has got one layer with three nodes. So the architecture is each input is given to each of the nodes. And each of them is weighted. So let me call this as W11, W12, W21, W22, W W31, W32. How I have written this is node 1, this is node 2, this is node 3. 2 से 3 1 3 2. Okay? So the first transcript is the node number. Subscript, sorry, first subscript is the node number, and the second subscript is the feature number. So W11 means X1 going to node 1, while W12 means, okay, so I have done a mistake. Let me rename it properly. There are conventions, so we need to follow them, otherwise आप read नहीं कर पाएंगे डेटा को, नेटवर्क को read नहीं कर पाएंगे. W1, 2, 3, so this will be W21, this will be W31. Okay? This will be W12, this will be W22, and this will be W32. This is how we write the weights on a paper. This is the standard convention. First subscript is the node number in the layer. The second subscript is the, what do you call it, feature number from the previous layer. अगर इसके बाद एक और layer होगा तो फिर हम उस तरीके से उसको name करेंगे depending upon कैसे करें. And then let me say that this goes as an output to a two-layer output where this belongs to class E1 and this belongs to class E2, and this will again be connected like this. जो भी रखना है CX, C0, CX, whatever it is. So this is a single layer neural network which has got one input layer, one output layer, and one hidden layer. Why we call it hidden layer? Because it is hidden away from both input and the output. It is something in between, where each unit of the hidden layer is a perceptron. So at node 1, what is happening is I am finding the local potential V1, which is equal to W11x1 plus W21 X2. Okay, am I right? This is what is happening now. The two inputs are coming and getting weighted, and I am writing them. Okay, and what will be the output of this node? It will be a non-linear mapping of V1. Am I right? And that will be the output of this node. And that output will be weighted by this over here, whatever weight I give over here, which I have not written over here right now. Similarly, at node 2, it will be phi of V2, which is equal to phi of W 1 2 1 2 meaning 2 1 नोट 2 है ना ओ तो यहाँ गड़बड़ किया है wait a minute what am I doing this should be 1 2 x1 plus w22 x2 and then at the node 3 it will be phi of w31 x1 plus w32 x2. You see, for the time being, let's forget the files and write this equation once again. V1 is equal to W11x1 plus W12x2. V2 is equal to W21x1 plus W22x2. V3 is equal to W31 x1 plus W32 x2. This is, please pay attention. Here is the beauty. What's going to happen? Please pay attention. This is equation, three equations in three unknowns. Am I right? This is three equations in three unknowns. So can I write this equation like this? Can I write it like this? Please have a look. It's nothing but multiplication of a two-dimensional vector by a transformation matrix W so that it becomes a three-dimensional vector. Am I right? Isn't it a kernel mapping? What did I do? I took a lower dimensional vector, multiplied with a matrix so that now it becomes a three-dimensional vector. And this is what the theory says. If I project the data to a higher dimensional subspace, the linear separability is going to increase. So I can now write this as V is equal to this vector V. Vector V is equal to this weight W into vector X. Am I right? This is what is happening as a transformation. And then on top of it, if I take the phi function, this will become a non-linear mapping now. And that's what the neural network says. By projecting the data from a lower dimensional subspace to a higher dimensional subspace by a non-linear mapping, you can increase the separability of the data. And that's what we have just done using a neural network. So had it been, what do you call it? 4 nodes, this would have been become a 4 cross 2 matrix, 4 rows and 2 columns, and then you would have got a 4-dimensional. Okay. Now, if I add another layer over here, this will become the input to that layer, and then another transformation will happen. Am I right? So that will be something like this. W11 prime, W21 prime, W31 prime, W341 prime, W12 prime, W22 prime, W32 prime, W31 prime, so sorry, 42 prime, W3, sorry, 13 prime, W23 prime, W23 prime, W43 prime, multiplied by the inputs V1, V2, and V3 would have given me an output V1, V2, V3, V4. Am I right? Okay. So by this method, by successively mapping the data to a higher dimensional subspace in each iteration or in each layer rather, see it boils down to matrix multiplication and nothing else. It's that simple. पता नहीं क्यों इतना भारी समझा जाता है. न्यूटन इतना खतरनाक क्यों लगा है? मैंने अभी कर दिया आपके सामने. It's nothing but the matrix multiplication. This is the projection matrix in the first layer. This is the projection matrix in the second layer, and so on. By projecting the data successively to a higher dimensional subspace, or maybe this would have been a 2x3 only, whatever it is, and then doing a non-linear mapping. Let me call this as V prime, then this will become V1, V2 prime, V3 prime probably, because the non-linear mapping would have gone over there. Okay, and this will give me P1, P2, P3. So now I can say that vector P is equal to this vector W prime into vector V prime. And then again I can take a non-linearity on top of it. And this is going to increase the classifiability. So by successively projecting the data over the layers, so if I have 7 layers in a neural network, which is called a deep neural network, that's the terminology we use. How many hidden layers are there? So if you go from a very large number, if you go to a very large number of hidden layers, it's called a deep neural network. So if I have 7 layers, what I'm going to do, I'm going to take this input x1, transform it non-linearly in the first layer. Whatever comes as the output will be transformed again by the second layer. Whatever comes as the output will be transformed by the third layer, and so on by the 7th layer. And that will finally go as the input to the output layer. Okay. And since the theory says that by non-linearly projecting the data from a lower dimensional subspace to a higher dimensional subspace by any kernel mapping can increase the classifiability. And for that, I give you the example that if I have a transformation which pushes the dots out of the board and access back into the board, I am going from 2-dimensional space of this blackboard to the 3-dimensional space of this room, and this blackboard or whiteboard, whatever it's called, becomes the hyperplane which separates the data. And with this, I rest my case. That's enough for neural network. इससे भारी कुछ नहीं है इसमें. अगर आपको ये भारी लगता है, then I cannot help. क्योंकि ये तो मैट्रिक्स मल्टीप्लिकेशन है जो कि आपने 11th स्टैंडर्ड में पढ़ा होगा. अगर ये भारी है तो फिर कुछ भी भारी हो सकता है. So neural network is nothing but matrix multiplication. आप ये matrix multiplication करते चले जाइए, काम हो जाता है. The trick is how do we learn this matrix? ठीक है? उसके लिए हाँ नहीं बैक प्रोपगेशन भी बहुत इजी है, बट आई एम नॉट गोइंग इनटू बैक प्रोपगेशन. ठीक है, उसके लिए फिर वेक्टर कैलकुलस की जरूरत पड़ेगी. आई एम नॉट श्योर आप से कितने लोग वेक्टर कैलकुलस जानते हैं, बट मैं समझाना चाह रहा हूं कि अगर आपको न्यूरल नेटवर्क की थ्योरी समझनी है तो दिस इज ऑल, नथिंग एल्स, और कुछ नहीं है. ठीक है, तो वी स्टॉप ओवर हियर. यहां के बाद कुछ नहीं. नाउ यू कैन प्रैक्टिस व्हाटएवर यू वांट टू प्रैक्टिस, जितना टाइम बचा हुआ है, क्योंकि मुझे नहीं लगता है इससे सिंपल किया जा सकता है न्यूरल नेटवर्क को. ठीक है, और अगर आप ये सब समझना है अच्छे से, हम लोगों ने जहां से पढ़ा है, तो साइमन हैकिंग की किताब है ऑन न्यूरल नेटवर्क्स एंड लर्निंग मशीन्स, जहां एसवीएम की थ्योरी भी दे रखी है, इसकी भी थ्योरी दे रखी है. आप वहां से पढ़ लीजिए, उसका पीडीएफ अवेलेबल है. ठीक है, ये सब कोई जो है आउट ऑफ द वर्ल्ड कांसेप्ट्स नहीं है, कोई बहुत सारी चीज नहीं है. इट्स ऑल अबाउट हाउ डू यू इंटरप्रेट एंड सी थिंग्स. आपको यूजुअली न्यूरल नेटवर्क ऐसे दिखाया ही नहीं गया. इट्स नथिंग बट मैट्रिक्स मल्टीप्लिकेशन. मैंने अभी सॉल्व कर दिया आपके सामने कि मैट्रिक्स मल्टीप्लिकेशन नथिंग एल्स. ठीक है, वी स्टॉप ओवर हियर. अब आप लोग चाय ब्रेक, लंच ब्रेक, जो ब्रेक लेना चाहते हैं ले सकते हैं. या फिर जो आपके पास कोड है उसको रन करके देखना चाहते हैं तो प्लीज रन कीजिए। अगर कहीं पर अटक रहे हैं तो मैं हूँ, अंकिता है, दोनों लोग बैठे हुए हैं, पूछिए हमसे, हम लोग हेल्प करेंगे रन करने में। और नहीं, अगर आप थक गए हैं तो मेरे साथ गप मार सकते हैं, इसलिए रिकॉर्डिंग को ऑफ करके जरूरत नहीं है। हाउ वाज इट? कल से ज्यादा अच्छा था कि कल ज्यादा अच्छा था? न्यूरल नेट समझ में आ गया? रेडियो बेसिस फंक्शन एक अलग तरह का कर्नल मैपिंग होता है। हर चीज के डिटेल जाना के लिए हिम्मत नहीं है यार। तुम आके खड़े होकर 1.5 घंटा बोलो, तुम पता चल जाएगा कि हालत खराब हो जाती है।